Hi team, welcome to Wiggins Maths. In this video we're going to be looking at another pure practice paper, Year 2, Year 13 content. Okay, once again I have got no previous knowledge of this paper nor the questions that are in it, so I'm going to be doing this live. Okay, so let's go for it, shall we? Okay, so the first question is to do with a geometric series. We're told the first term, so that's A, and we're told the common ratios, that's R, and the sum to infinity of this series is S infinity. We know it has a sum to infinity because R is between 1 and -1, and that is in our formula booklet, so we don't need to worry about that. Okay, so part A, find the sum to infinity. So the sum to infinity is A over 1 subtract R, and that is found in your formula booklet, which I've got open in front of me. So let's figure this out then. So 20 over 1 subtract 7/8, that's 20 over 1/8, which is 160. And you'll see that is worth 2 marks. Okay, the sum to n terms is Sn. Find to one decimal place the value of S12. Okay, so again, Sn we are given in the formula booklet. So 1 subtract r to the n over 1 subtract r. So 1 S12, A is 20, 1 subtract 7/8 to the power of 12, all over 1 subtract 7/8. Just type that into my calculator, being super careful not to make any silly sign errors, of course. Okay, so that comes out at 127.7732 and so on. So to one decimal place, that would be 127.8, 1 dp. Another 2 marks. And all we've done so far is just use the formula booklet. Okay, part C with 4 marks, it's going to be a little bit more challenging. Sum to infinity, subtract sum to n is less than 0.5. Find the smallest possible value of n. Okay, so this is a little bit tastier. So the sum to infinity was 160, and the sum to n we wrote down as 20, 1 subtract 7/8 to the power of n, all over 1 subtract 7/8. And we want that to be less than 0.5. Okay, so I can see how this is going to be a little bit trickier, but let's see what happens, shall we? So 1 subtract 7/8 is 1/8. So dividing by 1/8 is the same as multiplying by 8. So 160 subtract 160, 1 subtract 7/8 to the power of n, and we want that to be less than 0.5. Right, okay, so I can expand this. So subtract 160, add 160 lots of 7/8 to the power of n, and we want that to be less than 0.5. The 160 and the 160 cancel out. So now I'm going to divide both sides by 160. So 7/8 to the power of n is less than, so 0.5 divided by 160 is 1 over 320. And now I'm going to take natural logs of both sides. So I can write it as n ln 7/8 is less than ln 1 over 320. Now, just from experience really, I'm just going to double check what ln 7/8 is. Ha, sneaky. So ln 7/8 is actually a negative number. Okay, so when I divide both sides by a negative, it's going to change this inequality symbol. So n is going to be greater than ln 1 over 320 divided by ln 7/8. So let me just type that into my calculator. So I'm going to do ln 1 over 320 divided by that. So n is greater than 43.19 and so on. So therefore we can suggest that n must be equal to 44 in order for that statement to be true. Okay, so let's have a look at where some marks are for that. I suggest 1 for just substituting in what we know, 1 for rearranging, 1 for taking logs, 1 for your answer of 44, so 4 marks there. Good stuff, good start. Okay, question 2. So we have a shape there. Been told its length. Been told we've got isosceles. We should know it's isosceles because, of course, that is the radius. We've got 2 sectors that are the same. Okay, so let's go for it then. So show that the angle COD, which is this one here, is 0.906 radians to 3 sig figs. Now we can of course use this in parts B and C just to show that. I'm just going to make a quick note here. Might be useful later, but I should know that arc length is r theta, and that sector area is half r squared theta. Okay, and we can just get this generically from pi times diameter and pi r squared, and then changing it from degrees to radians. Okay, so that should work out reasonably well. So, right. So what do we know? We know. Okay. Yep. Sneakily. So we know that this is 8 and this is 8. The radius, as we mentioned earlier. So therefore, it's just a triangle. We want this angle. We've got all 3 sides. It's going to be the cosine rule, isn't it? So cos, I'm going to call it theta, is equal to 8 squared add 8 squared subtract 7 squared all over 2 multiplied by 8 multiplied by 8. So theta is equal to inverse cosine of that. So let me just type that into my calculator. Okay, so it comes out at 0.90563, which is 0.906 radians to 3 sig figs as required. Lovely. Okay, part B, find the perimeter. So in essence, we need to work out this arc, double it, add 7, add 16. Okay, so that was 0.906. So we can now work out these 2 missing angles because it's a straight line. And a straight line, 180 degrees, that's pi. So we're going to do pi subtract 0.906 and then divide it by 2, and that will work out what this angle is here. So that angle there is 1.12-ish. We'll call it 3 sig figs. Okay, so then if we take the sector, excuse the awful drawing there, 1.12, and we know the radius is 8, so we can work out the r length, so that is just r theta, so 8 multiplied by 1.12, which when typed into our calculator is 8.9423 ... Okay, so we've got 2 of those, so 2 lots of 8.94, add 7, add 16, which is 40.8847. 3 sig figs, 40.9 centimeters. Okay, lovely. And then find the area of the whole thing. Okay, so what have we got here? We've got our two sectors and we've got our triangle. So sector, let's deal with the sector first. Again, apologies for the pretty shoddy drawing there. But we've got half r squared theta. So half 8 squared, 1.12. Which when we type that into our calculator, we get 35.7694 ... Okay, and then we've got our triangle up here, that was 0.906, and we can use half AB sine C. So half 8 sine 0.906. Needless to say, obviously have your calculator in radians here, guys, otherwise it's going to go very, very, very badly for you. 25.185. So my total area is going to be 2 lots of 35.8, add 25.2, so that is 96.7 centimeters squared to 3SF. Right. Okay, so here, trig. They like trig at the start of this one, don't they? Okay, so let's do this first part, shall we? So r cos x plus alpha. So r cos x plus alpha. That is going to be equal to r cos x cos alpha subtract r sine x sine alpha, and we're going to equate the coefficients here. So 7 cos x, so therefore r cos alpha is 7, and then negative 24, so r sine alpha is equal to 24. We can use Pythagoras Theorem to find the value of r. So Pythagorean triple. Yes. Yeah, so r is 25. And then we've got tan alpha is 24 over 7. So alpha between 0 and pi over 2, generally between 0 and pi over 2. Alpha to 3 decimal places, so type that in to my calculator, and I get 1.1, no I don't, 1.287 to 3 dp. Hence means hence. So that was 25 cos x plus 1.287. 1.287. The minimum of cosine is -1. So therefore the min of this function is 25 multiplied by -1, which is 25. Just one more for that. Okay, and then we're going to solve it equal to 10. So that was 25 cos x plus 1.287, and we want that equal to 10. Okay, and we want x is between 0 and 2 pi, so we're going to look between 1.287 and 2 pi plus 1.287, just so we don't miss any solutions. Okay, so cos x 1.287 equals 10 divided by 25, which is 0.4. So let's get our principal value, shall we? Our principal value is 1.159, so on. Okay, I'm going to use a cast diagram. 1.159. We want cosine, which is also in the fourth quadrant, so 1.159. So let's get some values of x plus 1.287, shall we? So it's going to be 2 pi, subtract that for our other value here. So 5.1239. We could also get 7.44 218. We can also get 11.407. Do we need to do any more than that? Don't think we do. So x is going to be negative 0.128, 3.8369, 6.15518, and 10.12. So which of those are as we want them to be? Well, that's of no use. That's of no use. So is it 2 decimal places? Yep. So 3.84 and 6.16 are our solutions to this equation. Okie dokie. Oh, this one looks nice. Okay, so mass of a leaf after it's been picked from a tree is being given by this m equals pe to the negative kt. So it's just pe to the negative kt. Okay, write down the value of p. Okay, so the leaf is picked from the tree. The mass is 7.5. So that's when t is 0. So m equals pe to the 0. So 7.5 equals p. Done. Show that k equals 1/4 of ln 3. Okay, so we're going to substitute in our other information. So t is 4 and m is 2.5. And we now know the value of p, right? It was 7.5. So 2.5 equals 7.5 e to the negative 4k. So let's divide through by 7.5, which gives me 1/3, equals e to the negative 4k. I'm going to take natural logs of both sides. So that's going to be negative 4k. So we want it in terms of ln 3, and here we've got ln 1/3. Now 1/3 can be written as 3 to the power of negative 1, right? So I can write this as negative ln 3. I suspect that's where people might fall down on this question. So divide both sides by negative 4, and you're going to get 1/4 of ln 3 equals k, just as required. But it is a show that question, so we can now use that in any future parts. Find the value of t when dm by dt is that. So I suppose what we've got to do to begin with is differentiate it, right? So what do we know? We know dm by dt, but we know k and we know p. So let's just tidy this up a bit. I say tidy it up, it looks a bit of a mess, doesn't it, really? E to the negative 1/4 ln 3 t. It's pretty disgusting, really. So but exponentials, we like differentiating exponentials, so we're going to multiply by negative 1/4 ln 3, and then the exponential function stays the same. So let me just type this into my calculator, see if it gives me anything useful. 7.5 multiplied by negative quarter, negative 15 over 8. So we're going to get negative 15 over 8 ln 3 e to the negative 1/4 ln 3 t. There's a reason this is worth 6 marks, guys. So we want it to set it equal to that. So negative 0.6 ln 3 equals that. Which isn't too bad actually, because we're going to get lots of things that cancel out. So it's divide through by negative 15/8 ln 3, so ln 3's will cancel. Negative 0.6 divided by negative 15 over 8 is 8/25, and that is going to be equal to that. Take lns of both sides, so we can bring that horrible looking thing down. So ln of that is equal to ln of ln 3t. So the ln and the e cancel out, and then it's just a case of finally rearranging it. So t is going to be equal to, if I multiply both sides by negative 4, we get negative 4 ln 8 over 25 over ln 3. And I really hope this is going to give us a sensible answer. So let's type it into our calculator. We get 4.1486. And that does seem like a reasonable answer. That was tricky. Right, okay. Here we are, more like it, although more trig. Okay, so we've got a bit of a proof, hence or otherwise means hence. We've got to show that, and we've got to solve. It should be nice and straightforward, I'm hoping. Okay, so prove that. Since it's a proof, we must start on one side and leave the other side alone. I'm going to start on this side. There's plenty of stuff we can do here. Same denominator as well. So that's just write it like this to begin with. Okay, so sine 2x, there's only one way of writing sine 2x, so that's write that as 2 sine x cos x. Now, this is where we have to be a little bit savvy, I think. We know what we're trying to show. We're trying to show tan, right? So what we're hoping is to have a sine over cos in there somewhere. So I'm suggesting we rewrite cos 2x so it just contains sine. So let's do that. So that's going to be 1 subtract 1 subtract 2 sine squared x over 2 sine x cos x. The 1's cancel out, leaving us with 2 sine squared x over 2 sine x cos x, and we can see that this works beautifully, leaving us with sine over cos, which is tan, as required. But again, remember, we're proving it, so now we can use that fact to help us with the next part. And the next part is show that tan 15 is 2 subtract root 3. Okay, so that is a show that, it's not a use that. So we're just going to substitute x is 15, right? So 1 over sine 30 subtract cos 30 over sine 30 equals tan 15. 1 over sine 30 is 2, and cos 30 over sine 30 is root 3. Done. Seems very reasonable for 3 marks. And then finally, solve between 0 and 360, so degrees, not radians. Cosec 4x cot 4x equals 1. Right, okay. So there must be a link. It's not just going to be a random question here. It must be a link. So let's rewrite this. So cosec 4x is 1 over sine 4x. And cot is, I can see it now, cos 4x over sine 4x equals 1. So this is going to be equal, if we look up here and then look at this, the inputs are different, but this is going to be equal to tan 2x, which is a lot more manageable. Since the input is 2x, so we should probably have a think about up to 720 just to make sure. Principal value then, when is tan 1? When it's at 45, isn't it? Cast diagram, 45 there, third quadrant, 45. So we've got 225, and then let's go for another cycle, shall we? So we'll go for 405, and we'll also go for 585. The next one would be 765, which is greater than 720. And then just halve everything, so 22.5, 112.5, 202.5, and 292.5. Whoops. Okay, and we can substitute those back into here just to make sure that works, but I'm going to just trust that what I've done is correct. Okay, so this one looks interesting. We've got a massive fraction here, and we've got to show that, okay, that will be straightforward. Got nothing to worry about there. Hence or otherwise differentiate it. Again, that will be straightforward. And then calculate the range, 5 marks. Well, that'd be interesting. Let's see. So we want to show that it can be written as a fraction like this. So same as any other fraction problem, really. Let's make them have the same denominator. So we've got to multiply this first one by x squared add 5. So I need to multiply the top by x squared add 5. Add 4, we'll multiply it by x add 2. And then that third fraction is just going to remain the same. So let's just tidy this up, shall we? Let's expand those numerators. So we've got 2x squared add 10, add 4x add 8, subtract 18, all over. That is a shocking fraction line. However, we can deal with that. So let's tidy this up on the top. So x squared add 4x. And then 0. We know what we're trying to show, so there must be a factor of x plus 2 on the top, which there is. So take out a factor of 2x, we get x plus 2 over x plus 2, x squared add 5. Lovely, 4 marks, very, very generous. Okay, hence or otherwise, find h dash of x. Hence or otherwise means hence. Okay, so we've got function divided by function, so we're going to use the quotient rule. And the quotient rule is in the formula book. Okay, so the quotient rule is f dash of x, g of x, subtract f of x, g dash of x, all over g of x squared. So f dash of x is 2, d dash of x is 2x, So let's just substitute that in, shall we? So we're going to get 2 lots of x squared, add 5, subtract 2x lots of 2x, all over, of course this is dy by dh by dx, or h dash of x, all over x squared add 5 all squared. Okay, so let's tidy this up a little bit, shall we? So let's expand it and simplify. So we're going to get 2x squared subtract a 4x squared. So we're negative 2x squared. And we're going to get at 10. And I'm happy leaving it like this. Okay, that does the job for us. Lovely. Another 3 marks using the formula booklet. Okay, calculate the range of h of x. Now that's a really interesting one. So the range is, of course, the y coordinate. The y. So let's have a look at the graph. So it limits here, doesn't it? Okay, and what else do we know? We know that it's 0 here, so that could be useful. So that's a turning point. So that's probably what we're going to need to use here. So we're going to use our answer to part B, aren't we? Absolutely. So we're going to say that negative 2x squared add 10 over x squared plus 5 all squared, and the turning point is when that's equal to 0. So that must mean that we want 2x squared equal 10, x squared equal 5, x to equal plus or minus the square root of 5. We're told any constraint on x. X is greater than or equal to 0. Love to see it. Okay, so that means we're going to say that x is positive root 5. So if we substitute that in, so h of root 5, 2x over x squared plus 5. 2 root 5 over x squared add 5, so root 5 squared add 5. So we get 2 root 5 over 10, which is root 5 over 5. So that's going to be the maximum value, the maximum point. So therefore we can say that the range is between 0 and root 5 over 5. Lovely. Moving on. Ooh, tasty. See the power there, that stuck out straight away. Power there is x subtract 1. This is going to be a little bit nasty, I feel. Show that dy by dx at this coordinate on the curve can be written all sorts of things going on here, and lambda and mu are integers to be found. Right, let's see how many marks we can pick up then. So implicit as well, all sorts of things going on. So let's differentiate 3 to the x subtract 1. It is an exponential function, but the base is not e. So when we differentiate with base a, for example, we'll get a ln of that, and then it's going to remain the same exponential function. xy product rule, so differentiate x, leave y, and leave x, differentiate y. Y squared, 2y dy by dx, and then 5 is not a lot, and 0 is also not a lot. Okay, so the first thing we need to do is we need to make dy by dx the subject. So ln 3, 3x to the negative 1, add y equals 2y subtract x dy by dx. So ln 3, 3x to the negative 1, add y all over 2y subtract x equals dy by dx. Okay, we're getting somewhere at least. We were told the coordinate, weren't we? We were told the coordinate 1, 3. So let's sub that in. So we're going to get ln 3, 3 to the 1 subtract 1, add 3, all over 6 subtract 1 is equal to dy by dx. So that's ln 3 add 3 over 5. Okay, so let's think about this, because that's not in the format it wants. I suspect this is going to get us quite a few marks, isn't it? But it's certainly not in the form that it wants. So let's try and figure it out. So it had one logarithmic term, is what we're asked to show. So I can actually rewrite this 3. So it still gives me 3, but also contains a natural log. So I'm going to rewrite this as ln 3 add ln e cubed, which I know looks a little bit mad, but hopefully you can appreciate that ln e cubed is still just 3. But now we can add these two terms together, so we're going to multiply those parts, and we get ln 3e cubed over 5, and that's actually in the form we want, isn't it? So it's 1/5 ln 3e to the 3. That is properly nasty to spot that. Okay, I mean, I certainly nearly didn't. If you got to this part, I'm suggesting you're going to get the majority of the marks there. It is worth quite a few. I suspect this very last bit is what we call a separator question. It's separating those of you who are going to get an A star and those of you who might not. But that's a really tough question. Okay, more trig. Okay, and more implicit differentiation. So dy by dx in terms of x. So I'm going to differentiate it. So I'm going to get -2 sine 2x, subtract 3 sine 3y dy by dx, and when you differentiate one you get 0. So no, this isn't too bad actually. So we get negative sine 2x over 3 sine 3y. So we found dy by dx. That's not too bad at all. The point P lies C where x is pi over 6. Okay, so let's just write down what we've just worked out. So dy by dx was equal to -2 sine 2x over 3 sine 3y. X is pi over 6. Find out what y is. Okay, so we're not going to be using the differential in this one, are we? We're just going to substitute it straight into this. So cos pi over 3 add cos 3y equals 1. Cos pi over 3 is cos 60, which is half. So cos 3y, subtract that half, it's a half. 3y, when is cos a half? Well, it's when pi over 3. So that's going to be pi over 3. And therefore y is pi over 9. Pi over 9 is in that restriction there. Okay. I see. So now that's find the equation of the tangent. So we've got x is pi over 6. We've got y is pi over 9. And we had dy by dx was -2 sine 2x over 3 sine 3y. Yeah, So y subtract y1 equals m brackets x subtract x1. So let's find out what the gradient is then. So we want to sub in x is pi over 6 and y is pi over 9. So let's just type this into my calculator. Okay, so we just get negative 2/3. So y subtract pi over 9 equals negative 2/3 x subtract pi over 6. And we want it in this form here where a, b and c are integers, so let's just multiply everything by 3. No, let's go for 9. Let's go for 9 to begin with. Does that make sense to go for 9? Yeah. So 9y subtract pi equals negative 6. So 9y add 6x, and then we're going to get negative pi here, and then we're going to add, so it's going to be positive pi, so we're going to subtract that across, so negative 2 pi equals 0, and we've got them as a, b and c are integers. Okay, we've got a vectors question. Relative to a fixed origin, we've been told what a is, and we've told what b is. They're in 3D. We've got I, j, and k. First part should be lovely and straightforward. Find a, b. So let's do that. So a, b. So remember, a is OA and b is OB. So AB is going to be the position vector of b, subtract the position vector of a. I'm going to write it as column so that's negative 2 subtract 1 is negative 3, 2 subtract negative 3 is 5, and negative 1 subtract 2 is negative 3, and then I'm just going to convert that into IJK format. Okay, that's not too bad. Okay, part B. Find the vector of the equation line L. The points A and B lie on the straight line L. So what are we going to do here? So equation line, we use R, and that is going to be OA plus some amount of AB. So that's the general vector equation. So therefore R OA was I subtract 3j plus 2k plus lambda lots of AB, which is why we're asked to work out AB in the first part, plus 5j subtract 3k, wasn't it? Okay, done. Okay, so the point C has position vector that where P is a constant, given that AC is perpendicular to L. Okay, so it's perpendicular lines in 3D vectors. Doesn't get asked very often, this, so I won't worry too much about it. So firstly, we can work out what AC is. So that's OC subtract OA, using our knowledge of position vectors. So OC is 2P and negative 4. Subtract 1, negative 3, 2. So that is equal to 1, P add 3, and negative 6. Just check I'm happy with that. Yes. Yes, I think I'm happy with that. Okay, now if AC is perpendicular to L, it means that it's perpendicular to AB, right? Because AB lies on that straight line. We say that the dot product of AB and AC must be equal to 0 in order for that to be true. That's the rule for 3D vectors. So therefore we can say 1 p plus 3 negative 6 multiplied by AB, which was negative 3, 5, negative 3, must be equal to 0. So if you were to multiply each of the corresponding parts together, you're going to get negative 3, you're going to get 5 lots of p plus 3, and you're going to get positive 18. That's got to be equal to 0. So that's 5p add 15 add 15 equals 0. So we're going to get that p is negative 6. Okay, that's very, 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 very rarely in the Pearson Edexcel. So please don't worry about this question too much. And then part D, find the distance AC. Well, this sort of question is probably going to appear in the Pearson exam because it's just 3D Pythagoras. So AC was p plus 3, wasn't it? And we got p as negative 6. Okay, so 3D Pythagoras, so we're going to get the modulus of AC is 1 squared add negative 3 squared add negative 6 squared 1 10 36 root 46. I'll say this question is more aligned to other exam boards, but I thought it was useful to still go through this one. Okay, question 10, more trig, more differentiation. Parametric. dy by dx, so dx by dt using the chain rule, that's like u squared, so that becomes 2u du. So 2 sine t cos t, and dy by dt, 2 tan t is in the formula book at 2 sec squared t. So dy by dx is 2 sec squared t over 2 sine t cos t. And does that simplify at all? Well, the 2's will go, won't they? Is there anything else that cancels? Well, the sec can come down here, can't it? So I can rewrite this as 1 over sine t cos cubed t. You don't need to, it just might be a little bit nicer moving forward, especially when I'm having to type this into a calculator later. Okay, the tangent where t is pi over 3 cuts the x-axis at point P. Lots of information in this. Okay, so firstly, when t is pi over 3, x equals sine pi over 3 squared. So that's root 3 over 2 squared, which is 3/4. And y, tan pi over 3 doubled. Tan pi over 3 is root 3, so 2 root 3. And then we can work out what the gradient is. So dy by dx was 1 over sine t cos cubed t. So sine pi over 3 cos cubed pi over 3. Let me just type that into my calculator. Okay, so that comes out at 16 root 3 over 3. Okay, plug it into our formula, y subtract y1 and brackets x subtract x1. I'm going to multiply both sides by 3 initially, try and make my life a little bit easier. And then that's going to be 16 root 3, so it's going to be 12, subtract 12 root 3. Okay, I'm going to leave it like that because it's not really important at this moment. We want to find the x-coordinate though, but we are told that the it cuts the x-axis, so that means y is 0, doesn't it? So for y is 0, then that means negative 6 root 3 equals 16 root 3x, subtract 12 root 3. So that's 6 root 3 equals 16 root 3x. So x is equal to 3/8. So therefore p is 3/8, 0. Okay. Okay, substitution, integration by substitution. So first job, dx by du equals negative 2 sine u. So dx is equal to negative sine u du. Okay, some marks for that already. We can also sort out the limits. So root 2 equals 2 cos u. So root 2 over 2 cos u. So u, it's calculus, it's trig, so it's got to be radians. So u in this case is pi over 4. And then 1 equals 2 cos u. So u in this case is cos u is a half, and that occurs when u is pi over 3. So it's a good start, to pick up some marks where we can. It's going to be pi over 4, pi over 3, and it's going to be 1 over 4 cos squared u square root 4 subtract 4 cos squared u multiplied by negative 2 sine u du. Now this does look like a mess, doesn't it, to begin with? But I'm sure something magical will happen in a moment. We just have to spot it. Okay, so this sign is making me feel a little bit uneasy. So can we rewrite it in terms of something else? So 4 subtract 4 cos squared u. So that can be written as the square root of 4 lots of 1 subtract cos squared u, right? Root 4 is 2, and then the square root of 1 subtract cos squared u is sine u. Oh, that is absolutely beautiful, actually, when you think about it. That's quite difficult to spot, but this can be rewritten like this. So things are going to really cancel out now, which is great news. So the 2's are going to cancel, the sine u's are going to cancel, leaving us with negative 1/4, which I can take out, 1 over cos squared u du. So negative 1/4 between pi over 4 and pi over 2. And that I'm going to rewrite that as sec squared u. And I'm really happy to see sec squared u in this question because sec squared is in the formula booklet. So negative 1/4 out. Apologies. Negative 1/4. And the integral of sec squared is just tan. So it's negative 1/4. And that's going to be tan pi over 4 subtract tan pi over 3, which when we chuck that in, we're going to get negative 1/4, and we're going to get 1 subtract root 3. I'm just going to tidy this up then. So we're going to get root 3 subtract 1 all over 4. Okay, that is a pretty tough question, pretty tough substitution, but you can pick up loads of marks, limits, differentiate substitution, substituting as much as you can, you're going to pick up plenty of marks for that. Blimey, even more trig. Okay, so we can express it in terms of just sine and cos, and then hence show that, and then hence or otherwise solve. Okay, let's do this first one then. Can't be too many questions left, can there? Cosec is going to be rewritten as that. Subtract 1 over sine squared x. In terms of sine x and cos x, not 2x, so sorry about that. But we can rewrite sine squared 2x, because we know sine 2x, we can work out sine 2x squared. So that's going to be 4 over 2 sine x cos x squared. Subtract 1 over sine squared x. Okay, so 4 over 4 sine squared x cos squared x. Subtract 1 over sine squared x. It's just fractions, isn't it? So same denominator. So it's going to be 4 subtract. Actually, we don't need the 4, do we? We can cancel the 4's. So we're going to go for 1 subtract cos squared x over sine squared x cos squared x. And then from that, we can rewrite 1 subtract cos squared x as sine squared x. Sine squared x cancel out, leaving us with 1 over cos squared x. Beautiful. Hence show that written like that. Oh, I think I've done part A and part B in the same question. I think I've just gained 6 marks, guys, because I have done that, haven't I? Because I got to 1 over cos squared x, and that's equal to sec squared x. Don't worry if you end up doing that in your exam. Your examiner will spot it. It's not a big deal. Okay, hence or otherwise solve that. Okay, so we want to do sec squared x equals 4. So that's cos squared x equals 1/4. So cos x is equal to plus or minus 1/2. So let's deal with cos x equals 1/2 first. So that's going to give us pi over 3. What do we want it between 0 and pi? There aren't going to be any others. And then cos x equals negative 1/2. So my principal value here is 2 pi over 3. Okay, 2 pi over 3. Any others in the range? So 2 pi over 3. Nope. So therefore our values of x are pi over 3 and 2 pi over 3. We still keep going. Okay, so sketch these graphs. Ln x. Oh, okay. So first one, that's okay. So ln x, we should know what ln x looks like. It does that. It's the reflection of e to the x, so therefore that is the coordinate 1, 0, despite what it looks like, and we have an asymptote at x equals 0, so asymptote. Okay, anything else we need to mention? On each diagram, the point where the graph meets or crosses the x-axis, in each case state the equation of the asymptote. I'm assuming a couple of marks for that. Okay. Okay, so the modulus of fx, let's think about the last one. It went like this, so it's going to go like that, and then it's going to do that, isn't it? So that's going to be 1, 0, and we're still going to have an asymptote x equals 0. Lovely. And then third one, the trickiest of the three it looks. So negative f of x, that's reflection, and f of x subtract 4, so it's been translated to the right by 4 units. So we're going to reflect it and move it to the right by 4 units. So it is going to look like this. And we're going to have an asymptote here. X equals 4 is our asymptote. And it's now going to be cutting through 5, 0, isn't it? Okay, so that's just your graph transformations, really. And we are done. Okay, whew. So plenty of food for thought there. Please don't worry too much about the vectors question. That tends to appear on other exam boards to that extent. Make sure we're practicing. Make sure that we are asking any questions if we need to. And of course, amateurs call it genius, masters call it practice.